Is it always going to be like that?
Hold on, cowgirl.
Wait, is that the second one, the blue one?
The blue one is
one for
the second
y
one.
equals log base 4 of x.
Oh, right.
The green one is y equals 4 to the x.
They're always going to be inversed.
Those be inverses, which means
They're always going to be across from each other.
They're always going to be reflections about the line.
How do you know if it's down? Mine could look. Mine
Because
looks
it's
like
a
up.
reflection.
Mine looks like it's
I say we do a project on this.
Stop.
Oh,
That's a great idea.
Okay. Now, this is...
So if you know you did it right, it's because you see the reflection of the other one.
You see the reflection about the line y equals x, which is always a 45-degree angle line going through the origin.
No.
Never mind. Figure it out.
Double check.
I was thinking as
Okay, a couple of other points. To inverse... One other point on drawing these. To invert means switch, doesn't just mean switch the x and y points, it means switch everything about the x's and y's. So if the x-axis was an asymptote of the exponential graph, then the y-axis is going to be your asymptote of the logarithmic graph. So you have to draw it snuggling up to the y-axis, getting closer and closer to it, but not touching it. And you can't draw it curving away from the y-axis, because then it wouldn't be a function. Since exponential graphs, as we discussed with our grains of rice on a chessboard example, go up very, very quickly, logarithmic graphs must go to the right very, very quickly. When you invert the x and y, you're also inverting up and down, left and right. Does that make sense? So you really have to draw this so that it's snuggling up to the y-axis and going to the right, just as most of you did a good job of drawing the exponential graphs, snuggling up to the x-axis and going up.
Is this our homework today?
Yeah, but now I got to go into shifts.
No, this
Can we
is
just
like
I know we're trying to rush, but can we? I can't.
We're not trying to rush. We're just trying to get through the curriculum.
Wait,
I'm trying to avoid rushing.
I can't learn this all at one time.
Sure you can.
Wait, Mr. Abel,
Yes.
our shift's the one where we multiplied last time by the... Or we're going to have the x minus...
Let me go over it, okay, and I'll show it to you.
I have a question.
I have no doubt that you do, Amanda. Yes, Amanda, what's your question?
Ooh. Sorry.
Thank you, Nini.
So, would there ever be a problem like last night, or not last night, whatever, where it was like log base, I don't know, 5 and 125, and then you'd have to graph it?
Yeah.
Really?
Now, at this point, with what you know, can your calculator help you graph logarithmic functions?
Yes.
How do you do that?
In 2 cases. What are those cases?
When it's not a base 10?
Exactly wrong. Your calculator right now, with the buttons you have learned, your calculator can graph base 10 and base E.
Yeah, and I said when it's not a base 10.
But it can graph when it is a base 10.
Yeah, but when it's not, it can't, because you have to do this other thing.
Yeah, where's the base button?
Good. There is no base button.
It's what you said the other day.
You'll learn the trick later this week.
You said the other day that...
Okay, maybe. Thanks. It'll be easier if I just do this. Okay, now, Matt. You were doing a good job recognizing the pattern of switching from exponents and logarithms when it was numbers. Okay, I need you to do the same thing for me now on an example equation, okay? On a function. Are you ready?
Yeah.
Okay. So if I give you... Let me see if they have any... No, it's not multiplied by anything, which is good. So if I give you y equals... Is it all just... Nope, it's both. Log base 2 of x. I'll do it this way. Minus 4. That would be my first example. Log base 2 of x minus 4. How do you think you'd rearrange this to be an exponential statement?
Wait, what are we doing?
Same thing as a homework last night, where you rearranged logarithms into exponents and...
Ooh, I know. Can I do it?
Yeah, so what's the base? Jordan?
The base would be 2.
The base is 2. Now, I said the logarithm is a question, and the answer is always... what?
And the what?
The logarithm is a question, and the answer is always a... exponent. Very good memory. So whatever the logarithm is equal to...
Wait, I'm not done. Don't do it. Okay.
So what am I going to write here in the exponent spot?
You're gonna...
1.
No, yeah, 4x.
Stop.
Negative
Okay.
4, negative 4.
Amanda just had it. Now, the logarithm